Okay, calculus, let's talk 10.3, parametric derivatives and applications. So the derivative is normally dy dx, but if both of your functions are defined in terms of t, it's nice and convenient. The first derivative is just dy dt divided by dx dt. Don't get used to that. The second derivative isn't the second derivative with respect to t of each of those. Now, so find dy dx given x equals sine t and y equals cosine t. Well, if I just take the derivative of x with respect to t, that's positive cosine t. The derivative of y is negative sine t. So what's dy dx? It's just the division of those two, negative sine t over cosine t, or negative tangent t. Now how would that compare to our rectangular form? To get this in rectangular form, I know x squared plus y squared equals 1, because sine squared plus cosine squared equals 1, which means y would be the plus or minus square root of 1 minus x squared. We can worry about that more later. It's a circle in that case. Okay, so what's the derivative here with respect to x? Would be, if we just take the positive 1 minus x squared, be 1 minus x squared to the negative 1/2 times the 1/2 that would come down in front times negative 2x, which is the derivative of the inside. Negative 2 times 1/2 is just negative x. So that would be negative x technically over the square root of 1 minus x squared. Now, what is x? It's sine t. Now the square root of 1 minus x squared is just y. So this is just y because that's what it was equivalent to originally. What is y? It's cosine t. And what is negative sine t over cosine t? It's still negative tangent t. So it doesn't matter how you do it, it still gets you to the same place. So it's the same derivative. It's just with respect to t. Now the second derivative, d squared y over dx squared, is the derivative with respect to x of your original derivative, which means you have to take your new answer and take the derivative with respect to t and divide again by that same dx dt from before. So let's see how this works in an actual problem. Find the curve generated by x equals square root of t and y equals 1/4 t squared minus 4 for t greater than or equal to 0. Find the slope and concavity at 2, 3. So let's first find the slope. That's the first derivative. Derivative of x, which I'm going to call x prime, is 1/2 t to the negative 1/2. The derivative for y is going to be 1/4 times 2t, which would be 1/2 t. This is 1 over 2t, or 2 square roots of t. What happens when I do y prime over x prime? Be 1/2 t over 1 over 2 square roots of t. 1/2 divided by 1/2 will cancel, so this should just be t to the 3/2. Now, what time were we at originally? If x was 2, that means t was 4, because the square root of 4 is 2. So what is 4 to the 3/2? 8. So that means the slope at that point is 8. Okay, so let's talk about the concavity. I have t to the 3/2. That's something I have to take the derivative of with respect to t. So take the derivative of that. That would be 3/2 t to the 1/2. And I have to divide by that same thing I divided by before, 1 over 2 square roots of t, which is 3/2 t to the 1/2 times 2t to the 1/2. I'm just going to flip the denominator. T to the 1/2 times t to the 1/2 is t, so this should just be 3t. Because the 2 and the over 2 are going to cancel. And again, t is 4, so 3 times 4 equals 12. So that means we have a slope of 8 and a concavity of 12. So this is the basic idea behind parametric derivatives. We'll do more in the next video.